So this is Unit 5, Lesson 2. Today we're going to talk about one of the coolest looping structures there exists in any programming language. They're called for each loops. This exists in every language I've come across. There's some version of a for each loop. The syntax may be a little different, but it's all the same type of thing. Suppose we have an array list of strings called books. By the way, this is another way of declaring an array list. I don't like it all that much because I like to have, the parallel structure. You have to have string here. Don't technically have to put string here. Why did they make so many different ways of declaring it? I don't know. They just did. But I would keep it balanced and put string in both spots anyway. So we added in a whole bunch of titles, and then we print out books, and it prints out all of this. However, when it prints it out, there's no formatting. It just prints it straight across. So the way we would have handled this with arrays is we would have used a for loop, started at a particular index, and gone from 0 to the length minus 1. We don't have to do that with the array list. This is a looping structure called a for each loop. It moves through a collection of objects. So any collection of objects this looping structure will move through. For type E collection. I know that doesn't make a whole lot of sense yet. So let's take a look and see what this really looks like in code. But translation says for each element in E, the following collection do something. E is a variable, and the type is whatever is stored in the array list. If you don't have any particular type stored in the array list, in other words, you declared it without this declaration of string in front of it, then the type would be object. You would just use the word object as the type in that case. So here is how that loop actually works. For string B. So we're declaring B as a string, so there is a place to put the information. The array list is books. That's the collection. So in other words, for everything in books, one at a time, store each piece of information in the variable B, so we can do something with it. So we print out B, and then it loops back up to the top and gets the next value and stores it in B. We don't have to worry about the index. We don't have to worry about any conditionals in there. It is a much, much cleaner loop. You never have to know yourself how big the array list actually is. This is only going to work for an array list. It's not going to work for arrays. There are other structures called linked lists that we could do this with, but we're not actually going to cover linked lists at all. So for you guys, array lists are really the only thing that you're going to be able to do this with. So if we look at this example here, we have an array list of strings called breed. It's a new array list. We're calling the constructor. Again, you could put the string identifier there as well between the T and the parentheses. We're going to add in 3 things, and then we're going to loop through and print them. We know there's string stored there, so we're declaring the type. If we didn't know the type, or we had mixed types, different things that were in there, instead of saying string, we would say object. Some object that we don't know what it is. For right now, we know it's strings. Then we put the colon, then we put the array list, and then we do whatever we want with each individual element that's in the array list. So here all we're doing is printing it out. So how are these different than regular for loops? Well, regular for loops say do this some number of times. There's a set number of times that we want a task to be accomplished. The for each loops say do this to everything in the collection. Every item in the collection, do this thing. The for each loop totally avoids the one-off errors. In other words, at the end of the loop, you accidentally walked off the loop. You went past the edge. This totally bypasses that and avoids that. Because you never actually talk about the length. For each loops sound pretty good so far. So what I would like you to do is to write a for each loop that only prints out the books that have the letter C in them. So take our startup file and modify it so it only prints the books that has the letter C in them. So just a conditional to check to see if the letter C is there. Maybe use, let's say, index of. That sounds like a good method to use with strings there to check to see if the letter C is there. So pause the video, work on that, and then we'll come back and I'll show you the solution. Okay? So find the books that have the letter C in them. So the solution for this looks like this. You could have done, instead of not equal to -1, greater than or equal to 0. Same thing works. If b dot index of character C not equal to -1, print it out. Notice mine just checks for capital C's. So it's only printing them out with capital C's. If there was something with a lowercase c in here, this wouldn't work. So you'd have to think about that. Is that a solution, something we need to tackle? I don't know, did the original problem say capital C? Just look. Yeah, capital C. So, all right. So that's what you would look for. So you could change this to include the lowercase if you really wanted to, just by making this an or. B index of capital C does not equal -1, or, so that's the two vertical lines. B index of lowercase c does not equal -1. And then it would check for either one and include the one C in here. Where is it? I don't know, one of these got a C in there. Staircase, the hidden staircase. It would include that if we put that condition in. So if we compare this to a regular array, here's this regular array. We assign string titles. We fill it all up right away. We have our nice for loop here. For int I equals 0, I less than titles.length I plus plus. Then we have our conditional. And then we have this. This, I believe, is much easier to read. Like in terms of just reading the language itself. In terms of making sense. Add these books. It makes a lot of sense the way it's written. Print out all the books. For each B in books, so for each thing in books, if it's not equal to -1, print it out. Really clean. This is not. Definitely fine in terms of code. It's nothing wrong with it. But this is more readable. I like going back to talking about Grace Hopper. She's the one who did this for us, where she said computer language should be understandable. Where you should be able to literally read a program in your natural language and understand what it's doing. If you didn't know anything about computer science, this would be garbage. This wouldn't mean really anything to you at all. But even if you had a modicum understanding of logic, I think you could figure out what this means. This second case here, using the for each loops. So part of the reason for creating the for each loop is to make code more readable. We talk about comments and documenting your code. Part of comments and documenting your code is not just the double backslash that we use or the multi-line comment that we use, the backslash, the asterisk. Sometimes it's just about using good structure, good variable names, good method names that say what they actually do, as opposed to the jargon. In computer science, there is a proclivity to use jargon, things that people may or may not understand, and you kind of hide what your program does. There's a place for that sometimes. But for the most part, as a good developer, you should be choosing variable names and method names and class names that make sense, that someone could read who doesn't understand computer science code and have some idea of what's going on. So think about that as you write code. Could someone read this who doesn't know anything about code and understand at least a little bit what's going on here? And that's one of the advantages of using the array list, is because it makes sense. You could figure it out. So let's take a look at this. Why is this causing an error? Pause the video, think about this for a minute. So the issue in this is this line right here, the remove. If you take the example of the teacher passing out candy, and the kid who was first in line gets the candy and then walks back to the end of the line again, you've changed your list. Essentially, you're kind of throwing it into either a forever loop, or you know how many items are in the list. Java's still doing that when it does this command. It's just you don't have to explicitly say that. Java knows to count how many things are in this list. It uses the .size method somewhere. So somewhere there's code written that the for each loop uses the .size method to set itself up. Just like when you set up the for each loop, or your for loops using your index, use .length. You set that up. If somebody changes the length of the list, that becomes a problem, because it's already set up how long the list needs to be. So part of the clue here is the actual error is concurrent modification exception. Concurrent means at the same time I'm going through the loop, you're changing it. Don't change the loop while you're running through it. So the question is, can you modify an array list while in a for each loop? No, you can't. But you can do it in a for loop. You can do it in a for loop. So how does that work? Well, if we use the size command, right? If books.get.index of c, if for int I equals 0, I less than books.size, I plus plus. It runs. It doesn't quite do what we want it to, but it runs. Right? It finds Mystery of the Crocodile Island, but it missed the old clock. Right? It missed that. So we removed it, but it missed this. And then it found, let's see, then it found hidden staircase, but that's not a lowercase c, that's an uppercase C. And then it found the bungalow. There's no C in that at all. What's going on here? There's no error. The code actually works. What's going on here? So it goes through, and when it removes something, everything in the list moves. Everything gets shifted up. So what used to be the index I is no longer the index I. In other words, we removed all the things that were, we removed index I, but then everything got moved because we removed it. So index, what was I before is not I now. The list shifted. So this doesn't produce an error. The question is it possible to do something like this, to change the array and not cause any problems? Well, it has to do with how things are moved. It has to do with how things are moved in the list. We need to go backwards. If you take the list and remove something that you've already looked at, in other words, the end of the list, nothing else in the list is going to move. If you move something from the top of the list, everything in the list shifts up. So everything moves. So yes, you can remove things from an array list. You have to do it with a for loop, not a for each loop. And you have to remove it from the end of the list you've already looked at. So nothing shifts. We don't want things to shift and change all the positions. So we have to run through our list backwards. By going backwards, if we remove an element, we don't need to worry about it because the loop has already passed it, right? If we're here and we move to here and cut this off, this is never going to be seen by the loop. If we're moving forwards, we move from here to here and cut this off, everything to the right here shifts up. So everything is different now. Here, if we cut it off again, if we cut it off at the end, it doesn't affect all these others. If we cut it off at the beginning, all these others shift up. So that's one of the issues with the remove statement. You have to be careful that if you remove something from a list, it will change the order of everything else. For each loops won't let you do it at all. It'll say, no, sorry, you changed the size of the list. We got a problem. For loops, we're using the index and dot size because it's an array list. You can do that. You just got to do it from the back. So here's how this would look. We would look at the ending of the array in our for loop, greater than 0, I minus minus, and then everything works just fine. Okay? Then, of course, we just print it out using our for each loop to print out for each string in B of books, print out each value, and then we get all the values. Okay, so there is an exit ticket for this and a practice assignment. So this assignment here is part of a larger assignment. I know. Look at that. Called Strand. There's 2 assignments here. Right? Yeah. One's called Light. One's called Strand. So we're going to start by working on Light. There is a startup file for you. Actually, something doesn't. You know what? Hold off on that. Just do the exit ticket. Because it's asking you to write a class. Let me look. Actually, I think it's just asking you to write the methods in the class. Yeah, that's all it's doing. Okay, just want to make sure. You're not doing the whole class from the beginning. So you can work on this, the light assignment. If we look at the code, it's already given you all the setup. All you're going to fill in is the missing code for each method. You're going to have to use an array list when we get to strands, so think about that. And essentially, we're going to be turning lights on and off. And then we're going to take all those individual lights and put them in a strand. So this is 2 steps. Step 1, we're building a light. Step 2, we're going to build a strand. Don't worry too much about the structure of this yet, of how we actually build a class. You've seen classes before. You just haven't done anything with them yet. So all you're really going to be concerned about, much like you did in the labs, is filling in the missing code for the individual methods. All right?